moving on to question number 5. The identity of an electron in an atom can be expressed using 4 quantum numbers. So this is very similar to what we discussed in the early paper as well. And they are asking which is not acceptable as a quantum number for an electron in an atom. So first thing that you should remember again, what are the principal quantum numbers? Azimuthal, magnetic, and spin. Okay, just to make your life easier, okay, so we will say we have a principal quantum number n is equal to 1. Okay, so n is equal to 1 means there is only s orbitals present. So principal quantum number is this. Then you have the azimuthal quantum number. This will be in general, yeah, I will do this. This will be in general n minus 1. Okay. So if I put this as L, it is in general n minus 1. And then the idea is magnetic quantum number. This is in general from minus L to plus L including 0. Minus L to plus L including 0. Okay. So we generally say this is 2L plus 1. 2L plus 1, remember. Then you have spin quantum number. It will be either plus half or minus half. Okay. Now we will check the values. If it is n equals 1, it is S. So 1 minus 1, so L will be 0. So as you might think, ML should be, if this is 0, 2 into 0 plus 1 means it should be 1. But remember, that is not the case. If L is 0, ML is also 0. There is only 1. Then this will be either plus half or minus half. We don't know. It depends upon the S1 electron or S2 electron. Okay. Then we will go towards n is equal to 2, which means you have S and P. Okay. And if you consider a P electron, n is equal to 2, L should be equal to n minus 1, which is equal to 1. So remember, L is equal to 1 for P. So if L is equal to 1, according to this equation, 1 into 2, 2 plus 1 means 3, which you know that this goes from minus 1, 0, plus 1. So these are the 3 values. Okay. And here again it will be plus half or minus half based on the electron P1 or P2 or P3. Px, Py, Pz, you can decide. And if I go to n is equal to 3, where you have now S, P, and D, and if you consider a D electron, L will be n minus 1 will be 2 for a D electron. So here, if you put here 2 into 2 plus 1 means 5. So it will be minus 2, minus 1, 0, plus 1, plus 2. Okay. So you have 5. So in principle, this will be like Px, Py, Pz orbitals for P electron. For D electron, this will be like dx squared minus y squared, dz squared, dxy, dyz, d zx. So these are the 5 orbitals that is present in D. So these are the values that you can have. So the idea that you should know is like, if you are considering a S electron, L will be 0. If you are considering a P electron, L will be 1. If you are considering a d electron, L will be 2. Okay. Then based on that, you can consider this. This is an important equation that you should know. Ml will be equal to 2L plus 1. And these plus half or minus half based on the electron that you check. For an example, for a s electron, if you have an electron configuration like 1s1 for hydrogen, you can take plus half or minus half. For helium, you have 1s2. So for one electron, you have to take plus half. The other electron will have minus half. That is the idea behind this quantum numbers. Okay. Okay, so moving on. So we will go to the question now. So which is not acceptable? That is the thing that they have given. Okay. So how to check which is not acceptable? For an example, now we will take this one. So here first one, n is equal to 4. So n is equal to 4 means you can have S, P, D and even F. Okay. Then S, P, D, F, what is n is equal to 2? What is n is equal to 2? Sorry, L is equal to 2. So L is equal to 2 means it is a d electron. Now you have to think, okay, in n is equal to 4, can I have a value where L is equal to 2? So according to this principle that I explained to you, n is equal to 4 means S, P, D, F. So there can be d electrons. So yes, there can be L where which is 2. Okay. Then they have given ML as 0. So you know ML can be 0 because why? Why it can be 0? Because anyway, according to 2L plus 1 rule, it goes from minus L to plus L, including 0. So yeah, 0 can be a number. Then plus half and minus half, you don't have to think because it has a certain uncertainty. It can be either plus half or minus half. That's all. There are no other options that you can have. Okay. So this is okay. Now we will go to the second one where n is equal to 3. Now n is equal to 3 means what are the possible orbitals? S, P and D. Okay. So what are the possible L values? If you have S, possible L value is 0. If you have P, possible L value is 1. If you have D, possible L value is 2. So you can have either 2, 1, 0. Yeah, 1 can be. And if this is a pre-electron, there can be minus 1 to 0 to plus 1. This can be, and this can be. This automatically correct. Likewise, you can check all these. And when you come to here, the third answer, now see, n is equal to 3. Okay. So n is equal to 3 means L should be, according to n minus 1, it should be 2. Okay. So according to n minus 1, if L is 2, the only ML values that is possible is minus 2, minus 1, 0, then plus 1, then plus 2, as I explained to you in the board. But they have given for minus L, minus 3. No. It cannot be. Only possible value is this. So that is why this statement is wrong. Okay. And even when you practice like this, you can even imagine. Now, this is how, in principle, at university level or at higher level, they will basically not give you the electronic configuration in most cases. They will just give this set of quantum numbers and then you have to just identify which electron can be. Okay, so it is very easy. For an example, think about this statement 5. By looking at these two, I can clearly see it should be an S electron. Why? Because P is equal to 0, ML is equal to 0. So this should be an S electron and it is in the fourth. N is equal to 4. So N is equal to 4 means fourth shell means you have fourth shell, 2 elements which have S electron. Okay. Hydrogen, then lithium, then sodium, then potassium and calcium. So this electron can be either potassium or calcium because there is minus half. We don't know minus half is either for potassium or calcium. In that case, you have to use different data to find either potassium. We don't know. Okay. So I hope this sums up everything for you. So I explained to you a little more than the last paper, because last paper it was very straightforward, this with the set of principal quantum numbers to identify the number of energy levels, the electrons, or those things. But today it is little more towards the numbers. Okay. So this setups or sums up the entire story about quantum numbers.